Dimitri had an interview for a staff data engineer position with a hiring manager. Have a nice time watching. I want to know about you, about your experience, and why do you think you suit this role?
I'm Dimitri, working as a data engineer. My current project that I recently worked, it was building data warehouse for small startup company. And as a platform for data engineering, we used Snowflake. The backend of product was Azure. It was some IoT devices, and they generated telemetry, but the telemetry was sent into Cosmos DB by backend team. And Cosmos DB is NoSQL database, and my goal was to extract data from NoSQL database and push to Snowflake. On top of these, there were some other backend database in Azure, like relational one, also pushed to Snowflake. And a bunch, because they're selling devices like e-commerce through Amazon, through like online website, also integrate and bring this data into Snowflake. There I use dbt for data modeling, and then on top use the Sigma for the dashboards. And we also had two more people in the team, one like analyst/data scientist and one the product like manager analyst, who can actually use this data that I brought and do some kind of like analysis. Apart from these, there were integrations with different systems for the marketing, from Snowflake writing towards different APIs. And also we integrated with Amplitude, using this for the like product features. In terms of like we have mobile application, how the customer using mobile applications, it's driven by Amplitude, and it has direct integration with Snowflake. Tokyo Data is like a consulting boutique, and they placed people to the different projects. So it's just one of their customer.
Are you placed as a team or individually?
In this project is individual contributor. They, for example, this company, they didn't have their data team. They had desire to build the data warehouse because in the past they had some reporting solution on top of backend services. They decided to, they start building the data team. They hire like the manager and analyst, but they would need someone to build the infrastructure. And I'm a kind of person who built the infrastructure.
Why did you apply for this role?
A couple of reasons. First is I'm looking for the staff level roles. Second one, from like company perspective, it looks interesting for me. The devices, and yeah, for example, my current projects with also some kind of like devices, right? IoT device that collect the telemetry. And I worked in the past with Xbox, the devices that collect telemetries, and Amazon Alexa, that also devices with telemetries. More or less is have some experience working with device, and it's interesting then you not just working with software, but you actually have hardware piece that generating data, and then you can use this data for analysis.
Why did you decide to leave Amazon? What made you move?
Yeah, it's all related to career growth and compensation growth, either both for Microsoft and for Amazon, because those big companies are lots of bureaucratic process that hard to tie to your like delivery. So, for example, if I would know that I need to focus on political aspect of my career from the start, and for example, in Amazon, if I clearly identify 3 skip managers and make them happy, this will help me to get promotion. But I didn't know this. Yeah, I learned this very late. And in Amazon, I used to work in 3 different teams. Every time you switch the team, it's exciting because it's basically you switch the company, but you're still inside Amazon. But all your achievement reset. You start from scratch. And after my first switch, I was tired, you know, starting from scratch and trying to prove that I'm worth something. And then I switched to Microsoft and I got what I want, compensation, promotion, everything together. But so sometimes you realize, yeah, it's still the same bureaucratic process. And I was, in particular in Microsoft, I was working on dedicated project that was interest for me, implemented Databricks for Microsoft Gaming and migrate the legacy managed Hadoop and Hive to the Databricks and Lakehouse. And then after I finished this, it was clear for me, okay, it's still the same like political battle. And then I had this opportunity of Rocket Data. They offering good compensations, like different projects, and I know people from there. I decided to join them, and then I realized that actually working with consulting not that fun versus working in-house in one company.
Thank you for being transparent about this, but the staff position in our company consists not of politics, from my point of view, but communication on different levels.
No, for me it's clear, the expectation for the staff role and influence on the organizations, basically coming to impact. You have a bunch of engineers, senior, middle, they doing the work, and you serve as a leadership for them to help them unblock them, and also communicate with the business stakeholders in terms of what we want to build and why. And it's less of coding for sure, and more or like to be trusted partner for the organization.
Could you give me an example from your experience of how you implemented a solution from scratch?
When I joined Amazon Alexa, I joined the product organization. My manager was the product manager. I was the single engineer. They're responsible to build new features into devices, and they didn't build the features. My team is measure those features. All product managers across org, they have different features, different languages, locales. The goal was to measure the things. My team was responsible to building internal data products for how we're going to measure this. And we know where is the data, raw data. We know how to calculate the metrics. So they come out, there's analysts or like data scientists, they come up with the logic. And the team started just doing it manually every week, pulling the data manually, query a bunch of like sources semi-manually, and then combined together in spreadsheets. It took a lot of time, very inconvenient and unscalable. For me, the first time I was just looking what they're doing, to trying to identify the problem. Then the problem was clear, right? Like, okay, I understand what we want to build. Those kind of data products that product manager can come and slice and dice their features. I know the product manager's pain points. I know my team pain points. And then I come up with solution as a building central platform inside our like org, because the central storage for Alexa or anything on Amazon, it's huge. It's like petabyte size. You don't need all the data. You need just portion of this data. And then it sounds easy. You want to place like new platform, collect the data and calculate something inside. But you couldn't just go and build this. You need to get buy-in from stakeholders. And that's why in Amazon, they have like writing culture. Then you need to come up with proposal, and there are different ways. I chose the press release approach. Then I can write one page of the document about the future outcome of the project in like user-friendly language without any technical details, highlight the pain points and resolution. And then there is FAQ session. It's a very big session, or a big section with many questions that actually telling why and how much it cost. And this document, to create this document that's even like several pages, it took a couple months to reiterate with my manager, then their manager, before we actually can present and commit to build this. And you see, it's starting clearly from formulating the problem, and then you should write down the problem, and you go for revision first with the team, then with the manager, and then like skip manager. You collect the feedback, improve the document back and forth till you get the solid proposal. And because the goal is to collect all the feedback, answer all the questions, and come to the point that you're ready to make a decision, right? And because every decision has outcome with multiple options, you need to make sure that you highlight the options, pros and cons. It's clear for everyone, and then the team can make a call. And then after this, you commit or disagree. Someone disagree, but still commit. And then you start the execution and do the planning work, the sprints, the epics, backlogs, and so on.
We have quite the same documentation culture. Can you tell more about the technical part?
It was the consolidation of diverse data, especially like for different regions, because initially it was like querying independently different regions. Like it might be the same query but different regions. Consolidate all together, pre-calculate all the metrics, and automate the work. It's Alexa usage data. We built the data products for the product managers who can see their features, how the customers using them. Especially it's important for any new beta features, right? At any point of time you can product manager release a bunch of features. To measure them and track, you need to get the usage. Then you want to basically find your feature among all available features and see if this feature on demand or not. Or you starting new. We also, not we, but specific data science team came up with the quality metrics that can estimate is Alexa doing what it asked for. So like certain, but for this you also need the data. My goal basically to consolidate and bring the data in the single platform to apply the logic for calculations.
What was the singular platform you consolidated those data?
So we started from Amazon Redshift, and then we moved for certain workloads to Apache Spark and Elastic MapReduce, because it's for raw level logs that didn't fit into Redshift pattern. We just process them on site, not that frequent, like weekly. Just big pile of logs data that just doesn't worth to put in Redshift, and even just loading into Redshift takes a lot of time.
Did you skip the Redshift and directly put in EMR?
EMR process this. EMR the process raw level logs and save result in a Parquet. And then we used Redshift Spectrum to basically read external S3 buckets with Parquet files.
How did this solution improve the overall performance?
I had a kind of like hybrid solution, Redshift plus this like Spark, and I consider this as a Spark as a complementary service for the certain workloads that didn't fit into Redshift. So analysis that I did, so I'm able to process, for example, one file at a time. For it will take around 1 minute with my size of Redshift cluster, but I might have like thousands of files a day. I didn't find any way to parallelize this ingestion into Redshift, but in Spark, if I can just choose the big cluster and I can just point to the folder with all my bunch of files, and it will maybe running for like 2 hours and do the MapReduce and save the aggregated data in the Parquet. I save a bunch of time and money just doing it on site. And the source, not Alexa devices. There is one huge data lake available that maintained by another team.
Are there any SLA in the central data lake?
There are definitely SLA that you assume that data that you consume is accurate and refreshed. There are built-in alerts that you can subscribe, but it's your responsibility to react on alerts. It's up to the team.
What if there is a data quality issue? Was it on your side to capture it as well?
For myself, as a data engineer, any data quality framework is just must-have. Even simple checks, like there is no duplicates. I can compare today data volume with like past several days volume. Just don't see any spikes, any drops. But the typical, it's up to the team. If you want, you do. If you don't want, you don't do. But to avoid any issues with business stakeholders, it's a good thing to have.
For data engineers, data quality is important. What do you do to check it?
typical outcome of data engineering work is some metrics or insights that business rely to make decisions. The challenge here that you need to give them accurate data to make the accurate business decisions that will have impact, like on the organization, right? Then we build pipeline and integrate the data, not this any project. The data for data warehouse or data pipeline doesn't matter. Data in, data out. If you put the bad data in, you get bad metrics out. And you always have assumptions. Okay, data is accurate, and whatever business logic I got apply to the data and calculate the metrics is accurate. But there is, for example, framework that like test driven development, with the idea that any transformations you do, even it has test coverage. You can, for example, unit test for any functions you have for the PySpark. The challenge is, even if it works today, the goal is to, because the system constantly evolves and there are multiple people work on this framework, do the changes. You need to establish the framework that will prevent from any other engineer to make a mistake, right? You can merge the code or do the change that will reach some nesty joins. You miss the condition, the wrong condition join, so it can multiply the data. Whatever you build and evolve your system, it should already be covered with all kinds of tests to capture any spikes or any changes in the data. The same in this particular example, then I depend on upstream team with data sets. For me, it's in my interest to measure the input data quality. For example, I can simply measure today number of unique users with average last 4 weeks, or today hour with like 1 week ago, the same hour, the same day, or the same day, like trying to see what's the fluctuations between and because usually the data should be more or less in the band. The more test coverage I have, the more safe myself from reporting on bad metrics. Because if the metric is bad, I will get problem, not the upstream team. That's why it's in my interest, I spot the issue before it can be spotted by product managers. And if I spot anything, I can go directly to upstream team and ask them to correct it.
How do you automate the checking?
There are options. In AWS, we use CloudWatch, and we use Glue the Glue scheduler to execute on the server schedule queries that will collect the metrics and publish to CloudWatch. CloudWatch is basically have the different line charts, and then you set up alerts in CloudWatch. If threshold is broken, you get the alert. And also for the Spark particular, you can even adding test coverage inside the Spark using the library DQ for the Spark. And for Redshift, apart from all this like CloudWatch and everything, we used DBT. DBT has the test framework, and it has out-of-the-box test coverage for each table and each transformation, like DBT model. Simple rules like uniqueness, freshness, and not null. But you can also adding more complicated tests if you know that the you expected values should be in the certain list. Whenever your pipeline is running, for example, if DBT test is failed, your pipeline is failed, you get alert. If your Spark job is running and your assertions failed, the job failed, you get alert. If everything passes, then after completion of the job, these CloudWatch metrics generated, and then it will track result. If it failed, you get the threshold, you get alert.
Did you use DBT in Amazon? It is quite a recent innovation in the field.
It was like around 2020. So DBT still was on the market, not that popular like now. But in Amazon, usually don't. In Amazon, it's a very huge community. The community of like different data engineers and teams. It was the time then we, for example, adopted first the Delta Lake approach with Lakehouse. Before it was very popular. The same with DBT, because DBT gives you options to deploy it inside Amazon infrastructure, because it's just the package. And it means if it's packaged, you can just deploy it inside. You don't need any license. You don't need anything. And you can also integrate it version control. Also, for example, inside Amazon, you can use AWS, this code repo and everything, but we used internal for the version control, and like the Git system, it was internal based system. And then it wasn't my idea to use the DBT. I was just kind of, someone just introduced this, and then it's starting adopting.
How do you maintain DBT infrastructure?
Everything in terms like Amazon Teams, same for Microsoft Teams, usually it's valid like this 2 pizza size team. You have the small team. And I mentioned example, then there is the centralized team in Amazon, Microsoft. They build like huge data lake. So I consider them as just one of the extra source for my task. What they do, I don't know. They have their own things. For me, they just endpoint where I can grab the data. And then I have my own AWS account, and I'm building my own infrastructure, and I can use the different AWS services. At the same time, I can use internal services. The DBT end-to-end, it was basically attached to my Redshift cluster project.
Could you make an example of how you build a framework environment, not just for you, but for an engineer coming after?
It's quite simple. First of all, if you're able to leverage, because when you build a solution, you have no-code applications and code. If you have low-code application, then it's harder. But if you have the code, and for example, like DBT is a great example of this. It means everything is a code, and every change is coming through the pull request. It means there is certain process and standard of this life cycle to do the changes, starting from you create the branch, you work on the branch, and then to ensure and enforce the quality, you have the pre-commit. So as soon as the engineers work in the development branch, and another benefit of DBT, it has out-of-the-box development environment to hook to your schema and database. You can run everything in your development schema, you like it, you commit, and then you have the pre-commit option that will running some kind of tests, even like, for example, for DBT, it can make sure you have the documentations for the models, you have the tests coverage. You can also, when you create the pull request, you have the pull request template where you can specify what kind of things you expect in the testing section. Like you run the model, you see maybe if there is no impact. You can enforce this process a lot. Even if the person will skip the pre-commit step, just not install it, you have continuous integrations that actually will running everything in container and highlight if something off. And then you have in DBT particular, especially if you're using DBT Cloud, you have these options to hook DBT and running the stage. Your pull request will trigger to run DBT in staging environment, build the models using like your production data or some dummy data. And then only after all success in continuous integration, you can finally invite people to do the pull request. And then depends on the quality of outcome and the team capabilities, you can just do brief review of the code, or you can actually request that people who do the code review, they should run the code in their own development like IDE and running it locally to test it works. And then you have one more options like, okay, the code is approved. Before you deploy, you can run another set of the tests. And even if you're gonna merge it, you still have one more thing with releases. You can make sure that you do the code changes. You have the tagging system in Git system, and you have release, and you can agree that we do release once a week or once a sprint, and really release will include those things, those features. And then whatever tool is running code, for example, in your case, DBT Cloud, you can point to the container with the latest tag or the certain version of the tag. And even using the tagging, you can basically testing for different operations. You have some proof of concept, and you don't want to, you need to still merge it to production, but you don't want to run on latest. You can specify the tag, and you can use this production container with all the business logic in DBT and run it separated for the given tag. And the same The same approach I used with the Glue Spark jobs. I used the Terraform, and in Terraform, I have development, production environment. I had the unit tests running Glue Spark in the container, and there was a certain process how we deploy the models through releases and tagging. Our production model always had the certain tag. That's why whatever changes we do, even if we merge the production, without release, it doesn't matter because we're always pointing to the certain Spark job. It's just a Python file, so it has the tag in it.
Those are good principles of DevOps, and we lack it in data engineering.
I know what you mean because for my last couple projects, my first thing I did is actually those steps that I just highlighted. And especially if they have DBT, yeah, even just adding the, development environment in IDE, like in local, it helps a lot, right? We had like simple example, one company, they had development environment and the team was like 3 people, but they all built their models in the single development schema. There is the way you can, for each user, you can own development schema. It's already, and they all 3 person work in this single development schema. They like fight each other for overwriting. And then we used the Trino on Kubernetes. And the challenge was every time someone running the models in dev, they rebuilt completely production in dev pipeline, because if you have the fact table and you have all upstream dependency, and then I introduced a new feature, Defer. If you have the fact table and it depends on any numbers of upstream tables, the Defer command will point to the production. Your SQL model will generate it based on the production tables. This cut the cost, compute cost a lot, because you only run one model instead of like dozen models every time.
Is this approach applicable for big organizations? What do you think?
It's applicable for the big organizations. Then your data team might consist from multiple layers, starting from data engineer who ingests data, and then is analytics engineers, analyst, and machine learning team. So they have the certain expectations of the data, how they want to shape the data. And especially then we talk about telemetry, I assume is some kind of like nested structure events. And it is expensive to bring all fields into data warehouse. So you want to find the balance between what fields you want and bring and don't want to bring. The case that you mentioned, I assume it's straightforward, like data engineering team just assume that the certain columns will be nice to have. They integrate the data, they build the pipelines, there is the certain schema restrictions, everything available for downstream team to consume. And then they realize that IP address is not there. And then it takes effort to redo the pipelines, but redo pipelines is not a big thing. Usually for such telemetry projects, backfill is the most complicated and expensive thing. Volume of data is huge, and you just don't have the options to, let's just do backfill for last 6 months. Or maybe you already did the backfill. And then I had example with a fintech company where we have like BigQuery and Trino. The data was coming from Amplitude in the JSON formats. Oh no, it wasn't Amplitude. It was actually their product logs, and the product logs was written to the storage account. And the goal was to bring it to the staging and then do aggregation, because the data was such massive and the Trino was really constrained on the compute cluster. My proposal was to build the aggregation a certain level that the stakeholders can slice and dice it quickly for dimensions they need. So I collected requirements. It took me maybe 2 weeks to come up with logic and backfill everything. And it was running nonstop for 2 weeks because I have to iterate one partition at a time. I built everything. Product users start using this, very happy, very fast. And then there is coming another user say, everything fine, but can you add one more dimension into this data set? It means you should change the aggregation. And it means I need to backfill everything. Like what it's time, it's cost, and it's very hard. Yeah, I mean, maybe the right solution would be, I don't know, I skip the writing part here. I just, I meet with my manager, a couple other product managers. This is what we want. And it was like high leadership of the company. Yes, this is what we want. And instead of, just writing this document, distributing, because it was startup, it was really fast paced. So I just, okay, let's just go and build it. And then they come. And the challenge was, even if I'm going to add this particular column, they will come again to another use case. And they come over and over, there's new things. And that's why the writing is a good thing, right? And then you have different teams and you have responsible person. That's why I like different, for example, Rapid framework that we adopted recently. And it always has the decision makers. And you have the contributors, owners, decision makers, list of decision makers from different departments who gonna use this product. They sign off that this is what we're gonna build. And this will help such situation. At least it will protect you from the situation, oh, you just dump data engineer who didn't know what to build, versus okay, we agree on this and it's not what we want. Let's reiterate on this. It will just to protect yourself.
Unfortunately, we do not have any time left. You can send me your questions by email. Thank you, Dimitri. Goodbye.